previous video we looked at when we've got a function z in terms of x and y, how we can find the partial derivatives dz by dy and partial dz by dx with these sort of like curly v's. So if you didn't see that video, then be sure to check out that one before this. Now, when we've got a function y equals f of x, we know we can find dy by dx, but we can also find d2y by dx or dx squared, and so on. We can find further derivatives, so we want to see how we can do that for partial derivatives. And the difference with partial derivatives is that for y equals f of x, there's just one second derivative. There's the first derivative, there's the second derivative. I mean, for partial derivatives, we've already got, for a function of two variables, we've got two first derivatives already, and we'll see how many second derivatives we get. So if we take dz by dy, and we can partially differentiate this with respect to y, that's going to give us partial d2z by partial dy squared. Okay, so that's one of our second derivatives, and we're going to run through this systematically. So we're going to take these partial derivatives, and first we're going to look at dz, partial dz by dy, and partially differentiate it by x and y. So there are only two options. So now we take z partial dz by dy, partially differentiate with respect to x, and this gives us again d2z over partial dx partial dy. So now you can see, if you have something written like this, you differentiate z with respect to the one on the right, and then you differentiate that with respect to the partial derivative on the left. So you differentiate first with respect to y, then with respect to x. Now we're going to look at partial dz by partial dx. If we differentiate that with respect to x, we get d2 about partial d2z over partial dx squared. So that's another second derivative, and finally we can do d2z partial dx and differentiate that partially with respect to y. Okay, and so the question here is, well, how many second order derivatives do we have, partial derivatives, for this function z is some function of x and y? And it was clear partial d2z by dy squared is different from partial d2z over partial dx squared. So that's one. Two. The question is are these two equal? So is that true? And the answer is not necessarily. So this is true for many functions. But not true for all. So unfortunately you cannot use this as a result. So that's not true. So for certain types of functions, and you can look into that later, and this is true, but not for all functions head of x and y. So when you're doing, I don't know, proofs or whatever, or when you're just trying to manipulate functions, you can't assume this is true, and that's why I said earlier it's important to do this one first, this one second, and here this one's first, and then this one second. Okay, so the order matters here. Anyway, this was a little brief video on the second order derivatives. We'll do some examples in a future video, but for now, that's it. If you did enjoy, please like and subscribe, and I hope to see you in the next one.